Well, we can always then access by absolute row positioning, right? So we say give from row number 0 to row number 6, extract each row and look at what they are. And if there's noise, we cancel, we put a blank there or something, and then process them accordingly, right? So this is great that we are able to always have a way to refer to the cell, to the row, to the columns using absolute integer positioning, no matter what the labels are. And that's a cool thing that is very cool if you know it, but it's very frustrating if you don't. Now, since we are here talking about integer positioning versus label positioning, let me just show you another example why it is sometimes very frustrating. Now, suppose we relabel, reindex as called. That means we can assign labels, right? We reindex the labels because for some reason we like to call them 2, 3, 4, and 5, 6, 7. Okay. All right. Now you may say this is very artificial, but it could have been 1, 2, 3, 4, 5, 6 because certain natural applications we rather call the first row number 1, just like Excel, right? So in that case, something very strange, confusing, and dangerous, maybe even, uh, is happening here. Because if you're not careful, if you use the label way, I want the row with a label 2. We'll learn how to do reading back of rows and columns in a while, right? So if you say, using a pandas method function, and you say, I want a row with the label 2, it will return this row, right? We all agree because by label. However, if what you intend was to say, I want actually the position number 2, that means the third row, right? Zero base. So position number 2, but you use the label kind of function, you're going to get the first row rather than the third row. So if you use correctly the position based functions in pandas to extract position number 2 from the data frame, then you correctly get the third row. You notice that? Okay. So be very, very careful with understanding that there are two indices in some sense, right? So the dot index is something we can access, we can read and write and change in a way that's even duplicating the labels and having noise and garbage there. But there is also another parallel index that is position based, integer based. It's always absolutely labeled, and there's no way to change it. There's no way to change it, right? So same thing goes for the column. We can change the dot column values, the labels. So I'm going to use label to refer to the dot columns or the dot index all the time now, right? The labels can be changed, but the absolute integer positioning cannot be changed. And that is our North Star. That's our savior because nobody can change it. And so when we say the third row or the third column, it's always the third column, right? Okay, so keep that in mind, and that would save you a lot of nightmares. Now, on the slide here, we also see this dot log, and this is exactly what we perform row selection with. Now, the dot locate. Now, two things to note. This is dot locate. And maybe because of the L, I just take advantage of the L to remind us that this is a label-based method to extract the row. Okay, so we extract, how do I know it's label? Because it's LOC, but actually LOC just means locate the row with the label 5. So it's important to kind of speak softly in your mind that it is the label 5. It is not the 5th row, even zero base. It is not the 5th row. It is going to be the row which wherever it is with the label 5. Okay, so it will scan the whole index and select the entire row, like what is being highlighted here. All right, that has label 5. So far so good. Okay, now we can also use this. it's best to understand the dot log as requiring both row and column information. It's always row, comma, column, row, comma, column, row, comma, column. Never x, comma, y. All right, never x, comma, y or any other ways to refer to the xy axis. It's always row, comma, column, just like in mathematics. The matrix is always row, comma, column. So here, think of dot log as always requiring row, comma, column information. And the double colon, the colon here, just means start from not the very first column to the very last column, whatever they are labeled. Even if all the columns are named A throughout, the colon still works to say that the first to the last column, they are all calling themselves A. Okay, so that works. And if we so notice that we have supplied multiple columns and a single row. All right, multiple columns and a single row. We can also insert a list. Instead of 5, we can say a list of 5, 2, and it will extract row number 5 followed by row number 2 in that order. So 5 becomes on top of 2. So we can do that. And dot log can also extract by column, of course, right? So we can say colon, comma 5. That would mean error because we don't have a label that has a 5 there. Notice that you scan around, we have letters, we don't have 5. So we need to say colon, comma C, capital C, and then colon, comma capital C means all the rows at this column C. Yeah, okay, so we can do that. All the rows colon, comma B, capital B, the string capital B, then we can do this. So it's a bit like this, colon, comma, the string B. And as a short form, we can say DFB. And also as a short form, we can say df.log5. So notice the short form is short in different sense. Huh? So if we just say df.log5, it's like the comma, colon are automatically supplied. That means for all the columns, I want the entire row, with the row label being 5 here. Yeah? df square bracket quotation mark capital B is a very linguistically portable way. That means in other languages like R maybe and other JavaScript and all that, it is similar that when you say a table, I want that column label, then the entire column is selected. So that's why this short form of multi-row single column selection looks different from the df.log square bracket 5. And after a while of usage, you get to know. So in a way, you now get the sense that pandas treats the columns and index kind of slightly asymmetrically, right? It kind of favors a bit of more column-based kind of processing. And in particular, in pandas, columns have all the same type of data. So if we have H in column B, then all the second cell values in the rows will have integers, right? Then C, if it stores the salary as a float, then all the third cells in all the rows will have data type float. There is no way to do the other way around in pandas. So for example, if I want all the first rows to have integers, that's not possible. Okay, because it will be name, age, salary, etc., etc. So it will be string, integer, float, and so on. So across the row, it'll be a mixed types. And in this case, if we extract a row, because it becomes a series and the series requires all the cells to have the same type, pandas will automatically do the right thing to promote the type so that it will just call them object. Object can be anything. So it's still having the same type, but the type is a generic thing called object. So that's pandas' way of equalizing the non-homogeneous types. But across the column, automatically, internally, it's always the same type. So by birth, by design, by DNA, pandas treats columns with a lot more efficiency than across by rows. Yeah. So what that means to you is that the next time you need to represent your business application, you need to record name, age, salary, hobbies and whatnot. You want to start to think about names having all the names being stored as column in a pandas table, in a pandas data frame, because that would be more efficient. If you forcefully want to think about names, all the names are stored in row one. All the salary, they are stored in row two. Try to think about it in a transpose way, right? You flip across the diagonal so that you can take advantage of pandas design to make columns efficient. So there's slightly asymmetrical treatment there. And it affects us because if you don't design your representation correctly, it may end up being counterproductive. We use pandas to enjoy the efficiency, but end up you're spending a lot of time waiting for the results to come out when others have already finished computations. Okay. Now, we talked a lot about .log, .loc, and there's a square bracket. Even though it's a functional call, Python allows for the square bracket to be redefined as a automatic function call to do the right thing. There is a corresponding method called .ILog. So it is kind of suggesting it's locating exactly like .log, but the I here suggests that all the numbers supplied are by absolute integer positioning. Okay, it's not by label. So we were talking about the quiet parallel track that pandas is aware of, right? And we were saying that we need to be using the right function call or method to tell pandas to look at that invisible but definitely there sequence of numbers. So the way to do that is to use the I commands. So here we have, instead of .log, we say .ilog. 5 comma all the columns. So what this means is go to the 5th row, 0 base. So it will be this one. Go to the 5th row, okay, and extract all the columns. It'll be what this is. Now, what if we want to extract column B? And column B, unfortunately, is blanked out or something, right? Then the first one will fail because there's no column labeled B. Then what we can say is df.ilog, right? Across all the rows, give me comma 1 because it's 0, 1. Column B is the first column, 0 base, right? So we'll go across all the rows, and the blue box here highlights the cells that are being returned in the form of a series. Remember series? It's not shaped vertically, it's just a snake, right? And likewise, for the row with the position number 5, it is returned as a series as well. Okay, so those are the two very powerful main ways to access the contents by referencing the labels or the positions.